Woohoo, we're live. This is Math 40, elementary algebra. We're factoring. There are polynomials. Everything is going just bonkers up here. We're having a big old polynomial party, and it's time to factor some trinomials, three-termed polynomials. So, factoring trinomials is the bane of the existence of many math students, so there are a lot of different methods. I'm going to teach you two different methods. The first method is called trial and error. This is the one I learned. This is the standard from back before we had fancy ways of doing anything. So, I learned this back in the 1700s. And then there's also something called the AC method. It has a lot of names. So there are a lot of different names for this one, and I'll show you how to do this one as well for some of the harder polynomials. But I am going to stick to trial and error for all the polynomials on this page because it is pretty fast, and I think trial and error is actually the method that teaches you the most. The AC method is less frustrating for students when they start out. It's definitely easier when you start out, but it doesn't actually teach you anything. And in fact, a lot of times it slows you down. And so that's my concern, is that if you rely on the AC test method, it will slow you down a bit. Okay, so let's go ahead and get right into it. The idea behind this method, the trial and error method, is the idea that when you multiply out using FOIL, you get a first, an outer and an inner, and a last. And that's what we're going to be looking for, the first and the last and the ones in the middle. So how am I going to do this? Let me show you. So x squared plus 5x plus 6. This is the method. I'm going to look at x squared and I'm going to think x squared equals x times x. I know, earth-shattering news. I'm also going to look at 6 and I'm going to say, okay, 6 equals 1 times 6 or 2 times 3. I'll come up with all the ways to make 6 by multiplying. So I got one way to make x squared and 2 ways to make 6. I am now going to try these. That's the trial part, and probably make some errors. So in other words, I'll pick some to try. They may not work. That would be the error. So let me show you what this would look like. I would take this x times x and I would write this like that. And then I would write plus 1 plus 6. Notice I've set up two binomials, and then I would use FOIL, F-O-I-L. So let's do first, x times x, outer, x times 6, inner, 1 times x, and last, 1 times 6. So this ends up being x squared plus 6x plus x plus 6, and that gives us x squared plus 7x plus 6. Is this what we're looking for? No, it is not. We wanted 5 in the middle. We got 7. Okay, this one didn't work. Okay, let's try the other one. This is the one in the 6th one. There's another one right here. Start with x, but plus 2, and x plus 3. Okay, let's try this one. First, x times x, outer, x times 3, inner, 2 times x, last, 2 times 3. X squared plus 3x plus 5x plus 6. No, it wasn't. Do you guys see my mistake? I made a mistake. Oh, my funny brain. Let me find... Hilarious brain, always playing tricks on me. I'm going to fix this error so no one has to look at it. Sorry about that. I totally did that on purpose. See if I can cover this up. No one will see it. Ha, ha, ha. It'll just be our secret. I never make mistakes. I make mistakes all the time. Okay, so that should be 2x. Sorry, you guys all know where the 5 came from because I jumped the gun. I got so excited because we get x squared plus 5x plus 6. That's what we're looking for. So this is the correct factorization. So basically what we're going to do is we're going to use clues. This is very Sherlock Holmes. We're going to start with the answer and work our way backwards and try different things. And if we find something that works, awesome. And if we don't find something that works, either we keep going, or if we've run out of options, maybe we stop and say, you know what, we can't factor this. And if you can't factor a polynomial, you know what it's called? A polynomial that does not factor is called prime, just like a number that doesn't factor is called prime. And then technically speaking, all numbers factor into 1 times themselves, but you guys know what I mean. So like the number 3 is prime because nothing other than 3 and 1 go into it. Okay, shall we try this one? Now, as we're going through this, I'm hoping you're looking for other patterns because there is a pattern you can see to all of these on this page. Okay, x squared is x times x. 15. Well, that could be 15 times 1 or 5 times 3. Anything else? I think it's just those two. Okay, 2 possibilities. Let's try them. X plus 15, x plus 1, or x plus 5, x plus 3. Now, did you guys pick up on what the pattern is? If you look at these 2 options, we're looking for a number 8 in the middle. 5 plus 3 is 8. 5 times 3 is 15. 5 plus 3 is 8. I'm going to try this one first. Just because I make a list of them does not mean that I have to try them in the order I came up with them. Okay, so this will be x squared, outer, plus 3x, inner, plus 5x, last, plus 15. That's x squared plus 8x plus 15. Yay, we found it, right? Here's that 8. Here's that 15. This is the correct factorization. So you see the shortcut? We look for 2 numbers that when multiplied give us the last number and when added give us the middle number. Okay, this one's going to be a little bit more complicated because why? Well, because we've got a minus there. Also, if you look very carefully, oh my goodness, there are way too many y's running around. So what we're going to do right off the bat is if we see common factors, factor that guy out because otherwise it's just going to mess everything up and make it harder to work with. Okay. So I'm just going to look at the y squared minus 9y plus 20 part first. I have to remember at the end to attach an extra y on. Okay. Y squared is y times y. Now 20, you got to be really careful here. There are minuses. Since there are minuses, we need to use negative numbers. But this is a positive 20. So the only way to use negative numbers to get a positive 20 is to multiply 2 negative numbers together. So what does that mean? Negative 20 times negative 1. Negative 10 times negative 2. What else? Negative 5 times negative 4. I think that's it. Okay, so our options are y minus 20, y minus 1, y minus 10, y minus 2, y minus 5, y minus 4. Right? These are our options. We got 3 of them. Now, if you look at these 3, which one would you like to try? Given that we're going for a negative 9 in the middle, 20 and 1, 10 and 2, or 5 and 4. Yeah, I'm going to want 5 and 4 too. You know what? I'm going to try the other ones just for the heck of it, just to show you. Y squared minus y minus 20y plus 20. This ends up being y squared minus 21y plus 20. That's not what we're looking for. This guy is y squared minus 2y minus 10y plus 20. Okay, that's y squared minus 12y plus 20. Also not what we're looking for, but it could be, right? There are other ones that could be these. And this one is y squared minus 4y minus 5y plus 20. That is y squared minus 9y plus 20. Woohoo, we got it. We got to be careful though. Remember, we've pulled out a y up here. So we got to combine this. We need the y that we pulled out in the beginning. And you know what? I'm going to get my handy dandy yellow so that, because a lot of people will have forgotten this by the time we get here. Okay, that y from up there. And then y minus 5, y minus 4. So what are we doing? All we're doing is we're trying to go backwards with the distributive property or with FOIL. We're trying to figure out what the question was before we got to this answer. So this is the reverse of what chapter 5 did when we're in chapter 6. So, and I feel like I'd like to write one thing down. So if we imagine y times y minus 5 times y minus 4, and then we also imagine y cubed minus 9y squared plus 20y. Okay, so these two polynomials are equal. This is the factored form. This is the multiplied out form. If I go from here to here, if I get rid of the parentheses, this is called multiplying out. If I go from this with no parentheses back to this is called factor. So coming this way, multiply out. These two things are equal. Go this way, that's called factoring. This is the factored form. This form is multiplied out. Okay, whoa. Trying to get it all straight in the picture and everything. There we go. So what do you guys think? Does that make sense? I mean, obviously I can't hear you. If you're sitting back there going, wait, I don't know what's going on. This doesn't make any sense. I won't be able to hear you, but you can definitely email, text me, you know, all those things. But basically, you're going to spend the rest of math and we're going to say things like, we want you to multiply it out. So then you go to this form. And we'll say, no, we want you to factor it. Then you go to this form. Different things you're going to do with polynomials will require the multiplied out form or the factored form. So you're just going to have to read the instructions to know which one we want. Okay, when we come back, we're going to work on some much harder factoring of trinomials. Woohoo!